All right. So, like I said, I guess I'm Doug Sillars. I'm going to talk a little bit about making um, fast and beautiful images, how to get images delivered quickly. As I mentioned, I'm originally from Seattle, but I've been traveling around Europe, so I get to show cool pictures. This is Three Castle Head in rural Ireland, and I'll talk a little bit about rural Ireland in a second. Um, about a little bit about me. I've been doing performance for about 10 years. I worked for AT&T in America for a while, and now I'm working in a freelance doing developer relations, helping web companies make their websites, make their apps run faster by doing performance audits and workshops, teaching them how to improve just the general performance, improve the images, video. I do a little bit of AR, VR stuff. I wrote a book for O'Reilly. If you're interested, you can download it. That's the URL. And if you ever want to get in touch, I'm the only Doug Sillars on the internet, so I'm really easy to find. So before we really talk about images, I want to show this picture of the Alps in Switzerland. And I can't see faces here very well, but how many of you get nervous thinking about walking across this walkway that's literally nailed to the side of an Alp? I see a hand. I can see a couple hands. I see movement at least. Yeah, I walked across this with my family, and my daughter, who was 6 at the time, decided to jump the whole way. So it rattled as we were walking. It added a little ambiance to it. A few years ago, Ericsson did a study, and in that study, they put sensors on people's heads to understand stress responses to different actions. And they found that queuing up in line raised people's stress. They found that thinking about standing on the edge of a cliff raised people's stress. It raised, stress levels in their brains. But interestingly, they found that a slow mobile website is actually more stressful than standing on the edge of a cliff. So the feeling you were feeling about 90 seconds ago, where you were feeling nervous, right? If that's what your customers are feeling when they visit your website or visit your app, they're less likely to buy things. They're less likely to come back, right? Because if you go to the mall, it's always happy music. It's bright because if you're happy, you're more likely to spend money. But if you're already there and you're already frustrated, right, you're going to lose out on your customers. And there's a lot of research on this. Google found that a 3-second delay causes 53% of people to abandon mobile websites. A half-second delay causes an increase in frustration and a lower in engagement. 20 years ago on the desktop, Amazon and Walmart both found that they lose revenue for every 100 millisecond delay. But my favorite one is, of course, that 4% of people admit to throwing their mobile phones when the site is slow. And so when we think about what can we do to speed up websites and what can we do to speed up apps, I just looked at the top at 10,000 random websites. And if you look at the websites, yellow is JavaScript, so there's a lot of JavaScript. As websites get bigger, you can see how much images, the percent of images dominates what's being downloaded. I mean, it starts off at about 50%, but it goes all the way up to, 80% of all of the stuff being downloaded are images. So if we can optimize the images that are getting downloaded, we can make the page load faster. There's a tool built into Chrome DevTools. It's built into a bunch of other things. It's called Lighthouse. Does anyone know Lighthouse? I see a bunch of hands. That's awesome. And there's 4 image optimizations that are built into Lighthouse. So Lighthouse is a tool. You run this thing against your website, and it looks for ways to optimize the way it loads on mobile. The 4 optimizations for images are quality, format, sizing, and lazy loading. And the scoring has recently changed. It's now 0 to 1, but when I wrote the talk, it was 0 to 100. I think we can handle that math. That's probably okay. It's also built into Web Page Test, which is an awesome tool if you're building websites. You can test your website anywhere around the world. You can test it with different devices, different speeds of network. And there's another tool built on top of it called the HTTP Archive. And the HTTP Archive uses Web Page Test to test 4 million websites every month. And then it's all in a database, so we can analyze what's actually out there in the world. And I did this analysis on 500,000 websites to see how we're doing on these 4 image optimizations and what is out there and how we can improve those websites that are out live in production today. The first optimization is quality. And inside Lighthouse, Lighthouse recommends that you save all your images at 85% quality. And so you've probably seen this. You've got an image on your computer. You're saving it in Photoshop or anything else, and there's a quality, like a bar. And when you lower the quality, Obviously, the quality of the image gets less. But Google basically found that 85% is good enough. It'll look good enough for everybody. It's really easy to do. You can take an image using ImageMagick, save it at quality 85, and you get that image. If you want to use a cloud-based tool like Cloudinary, you can upload the full-size image. It'll give you a long URL, and you just put Q85 in the middle, and you get a quality 85 image. So it's a picture I took of Riga recently, 3.6 megabytes full size. When I save it at 85% quality, it's half the size. And you can't really tell the difference. The quality is just as good, but we've made it a lot smaller, so it's going to get delivered faster. So we go back, we look at the 500,000 websites. How is this working on the web today? And we find that 43% of websites pass, but a full third of the internet completely fail this. They're serving the images at full size. Of those images, of those sites that completely fail, the median website, so Lighthouse will tell you how much faster the page will be, how much less data it will use. The median website that's failing this would be 2.8 seconds faster on mobile and use 420 kilobytes less data. So that's a huge speed up just by optimizing the images. But we can actually go better than 85%. 85% is just like throw the dart at the wall. It works for most images and we're good. We can go lower, like 50%. You can see there's some kerning, right? On this projector, you can actually see that there's some weird stuff going on in the sky. It's half the size, but it looks bad. Some projectors don't show that. You can really see it at 20%, right? That image just looks horrible. So we know 85% is good. We know 20% isn't good, but where's that perfect spot right in the middle? There are actually tools that'll do this for you. There's Booterogly, and there's also structural similarity. And these are algorithms that basically find the sweet spot where the human eye, you lower the quality until the human eye can perceive a difference. And then you go up a little bit. So the human eye can't tell that the image has been reduced in quality, so why not get it to that level? Here's a tool actually by Tobias Boldoff, who's speaking tomorrow. It's open source. You can do structural similarity on an image, or you can use Cloudinary, Q Auto. It does it for you automatically. When I do that, the image is 1.46 megabytes, which is 400K lighter than the 85% recommended by Lighthouse. So the Lighthouse would give a perfect score at 1.8 megabytes, but if I can get it 400K less, that's even faster. I put those images through WebPage test to see how fast they would load on a 3G connection. And you can see the full-size image takes 21 seconds. The structural similarity takes 9.5, right? That's a huge speed up. The next optimization is image format. And there are a lot of different image formats out there, right? So these are the different sizes of the different formats from the HTTP archive, right? We've got lots of JPEGs. They're bigger. We've got PNGs. We've got SVGs. We've got WebP. Let's talk about SVGs first. SVGs are vector graphics. They're really great for things like icons. They're just drawn as vectors. And it's essentially XML. You figure out what the vectors are, it gets saved as XML. It's a text file. You can compress it. You can put it right into the HTML of your document, whatever you want to do. And because they're shapes, they're infinitely scalable. And so you can take this small Twitter icon and you can blow it up and it looks exactly the same. If you see pixels in the image, it's because PowerPoint doesn't support SVGs. And so I had to, anyway. But you can make mistakes with SVGs. And so here's an example of a website where they have this logo of a target, right? It's kind of a dot as a separator on the web page. And I was looking at this website and I'm like, that SVG is really, really large. So let's see what's going on. So I downloaded the SVG and it's a text file so I can open it up. And if you notice, it says like Adobe Illustrator and then it just goes. And you might be wondering like, oh, how much is there? Well, the file was 946 kilobytes. And so what I did is I put the cursor right here. I dragged to the bottom. I deleted, saved it, and it was 1 kilobyte. Right? So this is one of those like, I made an image. Maybe I should test it before I push it live. Right? Because it's a text file, I can gzip it or use Brotli and make it half a KB. It gets worse though because this website has an orange version. So we're now talking 1.8 megabytes of these logos when it could be 2K. Or you can actually use CSS to style the red one to turn it orange. So it could be like half a K of the SVG and then you can just style it. or you could do 1.8 megabytes. Right? That's a simple optimization. That's just something we should look at when we're building images, that we test it before we push it live, because that's an easy fix. I want to talk a little bit about PNGs. I was actually surprised by this one. I was looking around at different websites, and I started seeing websites that had images called screenshot, date, time, blah, 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 right? So they're using a Mac. They get the image perfect in Photoshop, and rather than saving it as like a JPEG or a format that's, really good, they just took a screenshot of their screen. And the Mac screenshot tool is really awesome. I use it in presentation. This is a screenshot of my screen, this tweet. But they're not optimized, right? And so because you're doing this and you're pushing these live to production, you're making your images larger than they have to be. So I actually took like 10,000 of these off the internet, and I wanted to see if they could be optimized. 86% of them could be made 50% smaller simply by switching to JPEG, right? 35% of them could be 90% smaller just by doing the optimizations I'm talking about in this talk today, right? So this is one of those, it's not actually a technical problem, it's a workflow problem. People are just taking screenshots and pushing them into production. I actually did an analysis because I wanted to see, are people just doing this like Friday afternoon? But it wasn't. It was a nice bell curve during the day, right? It was just during working hours that people were taking screenshots and pushing them live. Obviously, mostly during the work week, then on the weekend. But there's a great image format called WebP. And if I had been giving this talk a year ago, people would be like, yeah, but WebP, that's just Chrome and it's just Android. That's really not useful. We have a lot of users on a lot of different browsers, and that doesn't really work for us. But times have changed over the last year. We've got it in Edge. We've got it in Firefox. It's on most of the major browsers. There's one missing, but they're looking at it. So it could be that in the next year, it'll be in all 4 major modern browsers that WebP will work. And WebP images are a lot smaller in general than JPEGs. So if I take that image of Riga that was 1.46, it's now 1.46 megabytes. It's now under 1 megabyte by just switching it to a WebP. So I saved another 400 or 500 kilobytes. That's obviously going to download a lot faster. And it does. We save another 2.5 seconds, give or take. So you can obviously easily support for browsers that support WebP. You can serve it in a picture tag and then fall back to JPEG for all the other browsers. This is a lot easier if with only 2 formats. If it had been a year ago, you might have had to do 2 or 3 formats to get those better compressions for all of the browsers. But now you're just down to 2, so it might be worthwhile to look at. When I look at what's out there on the web, most websites aren't doing this. The Lighthouse data that I'm using is looking at Chrome, so it's looking for WebP, and 67% of the internet is completely failing. Of those sites that fail, the median site would be 4.1 seconds faster and use 605 kilobytes less data. Right, so that's a huge savings. That's a lot of data, a lot of speed up just by changing the format of the images on your web page. The third optimization is image sizing. And I think we all kind of understand this, right? So this is an image of a cathedral. The original image was 1.6 megabytes. It was 13 megapixels. I do all the optimizations that I just talked about. It's 800K, but it's still 13 megapixels. Right? And so the problem is if you serve 13 megapixels to a small phone, right, it has to download 13 megapixels. It puts 500,000 on the screen, and it has to throw away 12.5 million pixels. And the best analogy I can come up with this is when you order something online and a box comes to your front door and you get this big giant box and you open it up and it's mostly bubble wrap, right? And you have to go through all the bubble wrap to find out that like your kid ordered a pencil or, right? It's just wasteful. You didn't need to send that giant box. You could have just stuck it in an envelope and it would have been smaller. A lot of our images we're sending are way too large. And in addition to just wasting data and taking more time to download, there's a whole nother effect. That effect is when there's 13 million pixels and then only 500,000 show up on the screen, your phone or your device's CPU has to fire up and figure out which of those 12.5 million pixels to throw away. And if you look at it on the desktop, it took 14 seconds to download that large image, and it took 78 milliseconds to throw away all those pixels. Not a big deal. Motorola G4, which is sort of an older it was a high end when it launched, but now sort of a mid-range device, lower to mid-range device. It takes 200 milliseconds to decode those images. But the Alcatel One X is an Android Go device, and these are devices that they're selling. They're really inexpensive. I was just in London, and the Alcatel One X was going for like £35. Right? It's a super cheap device, so a lot of people are going to buy them because, if I drop it in a puddle, it's not a big deal. It was only 30, right? It's a really inexpensive device, but it's really, really slow. There's a great review of this that says your battery life lasts longer when you use this device because you'll hate using your phone. And so if you're not using it, obviously the battery life lasts longer. But it takes over 800 milliseconds for the CPU to fire up and to throw away all those pixels. Almost a whole nother second before that image can show up on the screen. It's just more delay. It's slowing down your site even further. By simply optimizing that image, it downloads faster. When we look at all of the Android devices that are out there, there are a lot of devices, a lot of different screen sizes. These are all the devices that hit Akamai in one day. These are all Samsung devices. Green means fast CPU. Red means slow CPU. There are a lot of those really slow, low-end devices that are out there. So what we want to do is generate a bunch of different sizes of our images. You could use your analytics to figure out what sizes you need to generate. If a lot of people on these different size phones, generate images for those users so it's the correct size. In this example, I generated, so all of my images are 25 kilobytes apart. I ended up generating 20 images, which is fine for an example, but it might not work if you have 100,000 images in your CMS. But I found the ideal size with the HTML. I've delivered the exact right size, and now I'm only wasting 100,000 pixels as opposed to 12.5 million. And that obviously is going to take a lot less time for the CPU to decode even on a really, really low-end device. So the tool I used was the responsive breakpoint generator. It's online. It has a GitHub repo if you want to just put it as part of your image processing. There are a lot of tools out there that will do something like that. In this case, I said 200, 1400, 25 kilobytes apart, and give me 20 of them. And it just gave me a zip file. When I load the right size image to the Motorola G4 that I was testing on, now it takes 2 seconds, and it's only 121 kilobytes. Obviously, that's a huge speed up, right? We just saved another 5 seconds in the download time of my image. When we look online from the HTTP archive, 500,000 websites, almost 60% of the web is doing this right and getting a 100% score. But 22% are completely failing. Those sites that are failing, the median site would be 2.7 seconds faster, save 420 kilobytes. So again, just one of these optimizations will do a huge speed up to your web page. If you can do all three, usually one gets you a big jump and then the others get you smaller jumps, but there's still a huge potential speed up for your web page just by optimizing the images. The last optimization I'd like to talk about is lazy loading, which is also in Lighthouse. And so the idea behind lazy loading is you have a web page like this. There are a bunch of images that are below the fold. They're not showing up on the screen when the page initially loads. So don't load them. Put in a placeholder image. Load them after all the content that your customer sees right away loads. And if you do that, the page is going to load faster because we just took 4 images out of the loading of the page. 60% of the web is failing at this, and those sites, I clicked too fast, would be 3.5. The median site, if they turned this on, would be 3.5 seconds faster, use 530K less data. What a lot of sites do, and you've seen this, Medium does this, Facebook does this, they put in preview images. So in this case, this is Google image search. I search for cats in costume. I slow down my network connection, and you see these solid placeholders, right? Pink for the cat dressed up like a bunny. Cat is a dinosaur, it's green, right? You see that it sort of matches. You know an image is coming, you're willing to hang out, and you know that it's coming. If you want to go a little fancier, you can make it an SVG. So instead of just solid green, it's sort of got some texture showing that it is waterfalls. It's a little fancier. This is 900 bytes. This is 120K. This shows up first, and then that pops into place. It's really, really cool. So I want to run a lazy loading experiment for you. This is a web page. This is the desktop version, and I just shrunk it down. And you can see all the red line denotes a screen. And so you can see there are about 5 screens on this thing. And when I load it up in Chrome, initially you just get the text. And then you start seeing placeholders come in, and then more placeholders, and you can see the text is reflowing all the way through. And then we start seeing images, but interestingly, at number 4, there's a cow that's fully loaded, but our customers still don't have all the images that they want to see at the top. Your viewer is still waiting for the page to load. Even though there's content way down below, they're not seeing it yet. And even here, you can see there's still a placeholder in number 5 on the top of the screen, but we've got images of mountains and buildings and cows and lakes and all that stuff down below. And that really doesn't make sense. We should load the stuff that our customers, that our users are going to see first, and then load everything afterwards. What's really cool is in Chrome 75, at least they're saying it'll be in 75, is lazy loading will be turned on automatically. And so this is behind a flag right now. And if you run it, what you see is what Chrome does is it requests the first 2 kilobytes of every image. And in those first 2 kilobytes, it gets the dimensions and the location of every image, so it can put in placeholders, and it can actually lay out the whole page right away. And and so in this case, I have those placeholders, and I have preview images in place, so these are all SVGs. But the whole page is laid out right away. And now that the whole page is laid out, the browser knows the order of the images, and it should only load the images from top to bottom. And so now the images load here first. The cow isn't here yet, right? The cow only loads way down here at the end. The images are loading the same order as someone would scroll down the page from top to bottom. So that's really exciting. There are a lot of lazy loading libraries in JavaScript out there today, but it's really cool that some browsers are actually implementing it too. So I'd recommend looking at the JavaScript libraries. They're all building in support for the lazy loading in Chrome, so it'll work both ways, and it'll pick the most optimal way. Now, beyond the Lighthouse stuff, there are other ways we can optimize our web pages. And I want to give a couple more examples. One is animated GIFs. Everyone loves animated GIFs. This was my goat back in Seattle. This is Nora. And I took a video of Nora, and it was 1.4 megabytes. We need fewer cats. We need more goats on the internet. So I made a GIF. But when I turned it into a GIF, it became 3.8 megabytes. From the movie to the GIF, it got 270% larger. And you start thinking about why is that? And so we'll turn back the clock to 1990, and we'll actually read the spec of GIF. And the spec actually says the GIF format is not intended as a platform for animation, even though it can be done in a limited way. Right? So the people who made GIFs said we shouldn't be using them as GIFs. And the reason for that is actually, it's not a movie, it's actually a flip book. So if you're doing 15 frames per second, it's actually 15 GIFs that just play one on top of one another. And so they get really, really large. And so what we should really be doing is serving our GIFs as movies. So if I turn that GIF, if I take the movie, I make it 256 colors, I remove the audio track, it's just 250K. And so you might be thinking, but Slack and Twitter and Facebook, they all use GIFs. I mean, you can actually see it, right? It says GIF in the corner, right? For those in the back, I made it bigger. But they're lying. If you actually open this up in DevTools, you can actually see that it's an MP4. So it's sort of GIF the medium, not GIF the format. So looping videos are great. And so what you should do, and you can also see that it's 396K. It's 400 kilobytes versus a couple megabytes for the animated GIF. So what you should really do is make it an MP4, put it in a video tag, loop, autoplay, muted, and you need muted on mobile. Videos won't autoplay on mobile unless you mute them. And that's because I think Chrome and Safari engineers sit in meetings too, and they don't want when they're not paying attention, they don't want the video to be super loud when it autoplays. If you're interested in Safari, you can actually put movies in the picture tag. And so this will actually loop if you put in all these parameters, it'll loop the goat video and then fall back to an animated WebP for Chrome, and then everybody else gets the GIF. And why that's important is that video is 4.5 seconds to load, whereas the animated GIF takes 22 on a 3G connection. Beyond the data savings, just the time to get that on the screen, it's worth it to serve it as a video. And that's why Facebook, Twitter, Slack, and everybody else are doing it that way. So There's a lot of ways we can optimize our images that we know we can do. We should be proactive. We should optimize images ahead of time to make sure that they're ready for all of our customers. But there are actually things that our customers can tell us. In the Chrome mobile browser, there's a setting called Data Saver, and you can turn it on. And what most people know about Data Saver is that Chrome, the Google servers, will actually proxy all the data and optimize the images and everything. Everything on HTTPS will be optimized through a proxy server. Through HTTP will be optimized through a proxy server. Anything sent HTTPS, they ignore it, just gets sent across. So if you have really inefficient images over HTTP, it'll get fixed with this on for your mobile users who have it turned on. HTTPS stuff will not be optimized. But what it does add is it adds a header that says save data equals on. So what does save data equals on mean? It's basically a header that tells the server, I don't want a lot of data. And so if your customers are actually telling you, I don't want a lot of data, maybe that's something we should listen to and serve them exactly what they want. And there was always a question like, how many people are actually using it? And so there was a tweet in October where he was looking at all of his data, and he actually sees that 5% of his users have this turned on. So with 5% of his customers saying, I want less data, he knows he can make his web page faster for those people by making the images smaller, by compressing them more, by maybe removing videos. Tools like Cloudinary, double-clicked, they will see this and they will automatically compress the images more. So this image, when I had it optimized for mobile, was 180 kilobytes using the Quality Auto. But if it sees the saved data, it gets a little more aggressive. And it makes the image, 50K, 45K less. It goes to the Eco version. So it's a little bit more aggressive. It makes the images smaller. And it does that automatically. So that might be worthwhile, right? Make your images even smaller for that 5% of people. It'll actually speed up the web page. Another thing to look at is there's an API. It's the Network Info API. And that API will actually tell you how fast your customer's connection is. So I spent a month in West Cork, in rural Cork, Ireland. And my Airbnb said high-speed internet. It had Wi-Fi. But what it didn't say was that Wi-Fi was connected to a 3G router that really only had edge coverage on a good day. So I was in this area that I had really, really, really bad Wi-Fi. And for that month, when I was on Facebook or when I was on Twitter, none of the videos showed up. None of the GIFs auto-played. None of that worked. And it's because they saw my downlink speed was really slow. So if I have a slow downlink speed, it was actually slower than 500 kilobits per second at this Airbnb. Those sites actually removed the videos, right? So if you see that your customers are on a really, really slow connection, it actually makes sense to remove that content from your website, from your app, because it's not going to work. And if it doesn't work, your customers are frustrated. If they're frustrated, they're less likely to buy things, return, et cetera, et cetera. So for that month when I was at our house at the Airbnb, video didn't work. But when I went into town, it all came back and it automatically worked because all of a sudden this API was saying I had a fast connection. So in conclusion, there's a lot we can do to optimize our images. We can optimize the quality, format, sizing. We can lazy load images. We can turn all of our animated GIFs into movies. I didn't talk about Base64 encoding images. Don't do it. It's bad. And then monitor what your customers are telling you. If they say, I want less data, serve them fewer images. Make it a lighter site for them. I didn't have time to talk about video, but I have my conclusions here, so I'll just go through it really quickly. I have seen websites with video that serve DPR, that serve Retina versions of the same video to mobile devices, and they didn't need to. I see lots of websites downloading full-size videos that don't even show up on the screen. Streaming is the best way, and that's a whole nother talk, but I'd love to come back maybe next year to talk about video streaming. Video and images can be really expensive. I had the opportunity to go to Russia last year, and I just wanted to see how much roaming was. And with my data plan, it was going to be €10.24 for every megabyte of data. And so you start thinking about these images, and you're talking like 20, 30 euros per image, not per web page, but per image. It gets really, really expensive. So we should think about, it's an edge case, right? People who are roaming in lands where it's very expensive, but it happens to people, and you hear the horror stories of it. and we should think about that because it does happen to our customers. So some of the tooling I talked about: web page test, HTTP archive, ways to optimize images, and then I talked about Cloudinary, which is a cloud-based tool to help optimize images. In conclusion, images can be beautiful and fast, and you should do everything you can to make sure that your images download quickly and look great. If you're interested in building with images, Cloudinary has a media developer expert program. You should look into it. They have a lot of cool features and things that help you out. You can email them there. With that, I'd like to thank you all for your attention, and I'd be happy to take any questions. Thank you very much.